Greetings and welcome, friends. We are talking today about names and types of angles. I completely forgot. Let me look up the name here. It's in 1.6. We're describing pairs of angles. But of course. So what happens when two angles get together? Like they become a super angle. That's what we're going to talk about today. It's going to be great. So here's some terminology for us. Complement with an E, not an I. Complementary and supplementary angles. So complementary angles are two positive angles whose measures have the sum of 90 degrees. Each angle is the complement of the t'other. I like it. So here's angle 1 and angle 2. Your complementary angles, they could be hanging out side by side, back to back, like a buddy cop angle movie. And those would be complementary. And when their powers combine, they're a right angle. But they don't necessarily have to be hanging out near each other. Maybe they just like call each other once every few months and they're still friends and they're complementary angles still, right? Right? But if they were to ever add up their measures, 20 and 70 still adds up to 90. Okay, so angles 1 and 2 are complementary angles. Angles A and angles B are complementary angles. Now, using definition of complementary angles, I could say, therefore, measure of angle 1 plus measure of angle 2 equals 90 degrees. And the reason that would be true is definition of complementary angles, right? And that's all you got. That's all you got to do, right? Remember, this angle 1 is referring to the picture of angle 1, whereas M angle 1 is the measure of angle 1, which is a numerical, right, number that represents the angle, right? Protractor stuff. Bam, you're good. So that's complementary angles, not to be confused with supplementary angles. Similar idea. Two positive angles. Wow. Does that suggest that negative angles could exist? Are. Interesting. Pre-calculus is probably when you look at some of that. Two positive angles whose measures have a sum of 180 degrees. So 180 rather than 90. Okay. All right. Each angle is the supplement of the other. So you could have two angles back to back forming what kind of angle is this? When it's a straight angle when when their powers combine, or they could just be like and like hanging out, and then but if you added up their measures, they add up to 180 degrees. And similar to like this, I could have said that the measure of angle C plus the measure of angle D is equal to what now? 180 degrees. And the reason that would be true is depth of supplementary angle. Okay, so there we go. Now I've already talked about this next type of angle. Are adjacent angles. Adjacent, right? I don't know. That's not just a math word. That's a life word, and they happen to mean the same thing. Actually, I think I've even referred to like work with an adjacent neighbor, right? I think I've used that terminology here already, perhaps. Complementary angles and supplementary angles can be, not necessarily, adjacent angles or non-adjacent angles. Well, I guess they have to be one or the other. Adjacent angles are two angles that share, wonderful, sharing is caring, friends, a common vertex and side, both of those things, but have no common interior points. All right, so this angle here and this angle here, they're adjacent angles because they have the come on vertex and the come on side, right? And together they're just hanging out side by side. In this case, these angles happen to look supplementary according to the sketch. Okay? But you can also just have like two angles that are adjacent to each other that don't necessarily add up to like 90 or 180, okay? Like so that these are like adjacent angles. They're just hanging out side by side. That's fine. And let's see. These are non-adjacent angles because they're not sharing the same vertex or a side. Okay, here's a question. let me do this. Man, I'm not good at these lines anymore. Here we go. Angle 1 and angle 3. Are those adjacent angles? Angle 1 and angle 3. Look at the definition. Common vertex? Check. Common side? No. All right, so they're hanging out close to each other. They've got something in common, but they are not adjacent to each other. All right? All right. No es más mal, right? These are just words. I think you've probably seen these words show up before in math worlds that you've been in and enjoyed. I don't know. I'm assuming so. Oh, we're missing it? All right, here. All right, internet friends, you guys can scrub ahead. Angles. Do I have any angle stories? To fill this time with. Angles. Yeah. Angles. I don't know. Stumped. All right, so we good? We good? This is also in your book if you end up filling it in a little bit later. Example 1. Identifying pairs of angles. In the figure, name a pair of complementary angles. Thoughts? Which angles? Oh, wow, this is tricky sauce. Which angles are complementary? Complementary means they add up to 90. So I'm guessing this one's excluded because it said they had to be positive angles. Right, my friend Alyssa? So it looks like 3753. Oh, I should name those angles. I can't just refer to this as angle A because there's too many angles that happen to hang out at A. Angle cab, I like it. Angle cab and angle S, because there's only one angle that's labeled here that's hanging out at S, are complementary. My writing tablet's working a lot better right now. I'm happy. Part B, and a pair of supplementary angles. Supplementary angles. Looks like, oh, CAD and angle S. That looks like, oh yeah, those nombres, those add up to 180. So I'm going to say angle CAD, computer-aided design, represent, and angle S are supplementary. And I mean, if you think about the word supplements, right? I don't know if you've like take vitamins or bodybuilders or something like all of us are. Supplements are the things you take that give you the nutrition that you were lacking in your regular diet, right? So it's kind of like, you know, they added up to being the thing you needed, which in this case was a straight angle. Right? Right? Not that bad, right? You guys are going to be experts at this. Seriously, this is going to be the best test on Monday. All right, where am I at? And click. Oh, finding angle measures. Let's look at part A here. Angle 1 is a complement of angle 2, and measure of angle 1 is 62 degrees. Find measure of angle 2. Now we're going to do this, and I'm also going to justify this along the way. So check this out. I'm going to say, what am I going to say? Measure of angle 1 plus measure of angle 2 is equal to what now? 90 degrees. Why is that true? Def of comp. Bam. Right, there we go. All right, now what can I do that would be helpful? I have another fact. I can say 62 degrees plus measure of angle 2 is equal to 90 degrees. Why is that true? Anybody know? Substitution. Subs prop. Right? If those two things are equal, then I can interchange them at any time. So if measure of angle 1 is truly equal to 62 degrees, then I can substitute it in and replace it, my friends, and you didn't even know. How sweet is that? Okay. Let's see. Now I've got measure of angle 2 is equal to, what's that, 28 degrees? Did I do the math right? I think I did. Why is that true, though? Does anyone know what I did that made that true? I didn't show the step, but I subtracted this from both sides, right? Minus 62, minus 62. That's called the subtraction property of equality. Okay? Subtraction property of equality. Right? So I just justified that. They're not looking for you to do that, but I just figured I'd point out those things because these pieces will become significant next chapter even, oddly enough. Let's see here, more quickly, I would just say measure of angle 3 plus 47 degrees is equal to 180 degrees. Measure of angle 3 is equal to 133, right? Yeah. Yeah, you guys are good, right? And tell you what, we'll even throw a B here with a closed parenthesis. That'll be fine. All right, I'm gonna skip that. Ooh, here we go. Oh, guys, soccer. I told you. I had a hunch. Here we go. This is so gonna help you. Oh, let's actually get this picture right here too. Oh, this guy, guys, this is so great. Get ready to pay attention like you've never have. Whoa, look at this. What? Wow, look at that. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Wow, guys, this is so great. And you guys do this at soccer practice all the time, from what I understand. Algebra, angles, supplements. Right, there we go. This guy, this is what he's imagining right now. Actually, wait, he wouldn't have the, yeah, he would do this. Right, he's thinking this. That's what winners think about, friends, when you're playing soccer. Okay, so here we go. If they're supplementary, and this is the big angle here, and this is the little angle there, I could say that, what, 4x plus 8 plus x plus 2 is equal to 180 degrees. Reason that's true, definition of supplementary, right? That was the clue. This guy, he knows what's up. He knows what's up. I think this foot's going to go like this. Bam. And then the soccer ball is going to follow some sort of a parabola unless he puts spin on it and we take, wind resistance into account. So here we go. Combine like terms. Forks plus x. Those are friends. We've got ocho plus doso. Those are friends. Combine them. 4x plus 1x is 5x. 8 plus 2 is 10. Equals 180. Subtract 10 from both sides. 5x is equal to 170. Divide both sides by 5. X is equal to 17 times 2, 34. Did you guys just, how did I just say 17 times 2? Does anyone know? Because I asked the question, how many times does 10 fit into 170? Which is 17 times, and I was thinking 5 goes in twice as many times. 17 times 2, 34, right? There's some math for your friends. There's some math. Now, let's see, did I actually answer the question? No! They want the measure of BC, right? So the measure of angle BK, BC, is going to equal 4 times 34 plus ocho. Man, don't even kick that ball yet, mister. You've got more math to do. 4 times 30 is 120, plus 4 times 4 is 16. 120 plus 16, 136 plus 8. We feeling it, friends? 144 degrees. Now, I've got two ways I can find the other angle. What's the easy way? Yeah, let's just subtract, 144 from 180. This is just going to be 36 degrees. Okay, so I could have, I could have like swapped it, plugged it back in, done all that, but here we go. Oh man, we got more to go. All right, more vocabulario. We're cruising, friends. Seriously, the math of this is going to be so easy. It's just a matter of like learning vocabulary today. And also being a pro soccer player. That helps. All right. Linear pairs. So we've already described supplementary angles. We've described adjacent angles. Here they said if you have two adjacent angles, they are a linear pair when their non-common sides are opposite rays. Okay, so opposite ray. There we go. Or they form a straight angle, you could argue, is the same thing going on there. The angles in a linear pair are also supplementary angles, which actually this part right here, I usually refer to as the LPP, the linear pair postulate. Yeah, you know me. Linear pair postulate, linear pair angles are supplementary. They add to 180, right? You got it. Good stuff, good facts. So linear pair, whoa, I undid it too far. Okay, so linear pair, they just are a supplementary set of angles, right? That are, these ones, by the way, have to be adjacent. Supplementary angles, they could have just been hanging out across space and time and happen to add up to 180. These ones must be mandatorily adjacent, okay? So linear pairs are more restrictive than just plain supplementary angles. Then here we go. Vertical angles. Two angles are vertical angles when their sides form two pairs of opposite rays. So here we go. Here, 3 and 6 are vertical angles, as well as 5 and 4. And I just labeled these as being congruent to one another. That's something that we will prove, but I don't think we'll prove it right now. Guys, this is all just words, right? This is great. You guys know words. You speak English, I think. And it's just math and words, and you just memorize them, and then you do them forever. So linear pair, vertical angles, actually the proof of those angles being congruent will require the use of linear pair postulate. Yeah, what's up? Yeah, those are other facts that come out of the definition. That's not like the way they chose to define it, but that's also true. So like that definition also has a bunch of implications that follow from it. Let's see. Yeah, you guys might not be able to keep up with all of it. Just draw the picture. You'll be good. You'll be good. We're just going to keep cruising here. So, identifying angle pairs. Example 4. We're going to make this, guys. I think we're going to do it. So let's see. Identify all the linear pairs. Okay, so here we go. I'll do A in green here. Linear pair. Do you see a linear pair? Ooh. Now it says linear pair, not linear triple. Huh. Well, here's a line. Angles 4 and 5. Right? Those are a linear pair. If they, oh, do you have a suggestion? Yeah. Well, I was going to say, like, if they're permitting this, I would say that angles 1, 2, and 3 are like a linear triple. Or here's a line, angles 2, 3, and 5. Like, that's a linear triple. If I had a name for this, like the 2, 3 angle, right? If I was allowed to say angle 1 and angle 2, 3 or something like that, but Do we see another one? Oh, 1 and 4. Good eye. Man, why am I not spotting that? Is that the one, Eliza, you were going to say? Man, I was causing all sorts of doubt, and it's just because I didn't see it. We just had to look at it a little differently. Wow, there we go. All right, those are the real ones, but I do want to point out, like, linear triples kind of exist. Let's consider part B, all the vertical angles, them verts. I think I already labeled them. Angle 1 and angle 5. Are there any other hidden ones? If it was allowed, this big angle here is a vertical angle with which two? Yeah, the 2 and 3 combo, right? So you could, if I had a way of naming this, if like they gave me, you know, like the A and the B and the thing, I could have said angle, you know, 4 is a vertical angle with angle ACB or something like that, right? But they didn't give us that option, okay? So yeah, so there we go. Is there another one? No, I don't think so. Not that they gave. All right, okay, here we go. And guys, I'm sad. I don't think we're gonna get to Class Quest again. So sad. Makes me cry on the inside. All right, this one, I mean, you guys are gonna be experts. I'm telling you, you guys are gonna be expert geometricians by the time we're done. Two angles form a linear pair. The measure of one angle is 5 times. I put a question like this on the test. Wow. The measure of the other angle. I'm glad we're doing this problem. Find the measure of each angle. Okay, so this drawing would not necessarily have been provided. On the test, it is not. So you would have drawn a picture, labeled one angle X, and the other one, whatever number times X that happens to be. And I know that they're a linear pair. Because they're a linear pair, what could you tell me about this? They add up to 180 degrees because linear pairs are supplementary, and supplementary angles add up to 180 degrees. Let's see, then we could do some solving. Find like terms to simplify. Oh, wow. Seriously, you guys should like auto-tune my voice, stealing the sound bites from my YouTube videos. Can't wait. Can't wait. Can't offer extra credit for it. I also won't give you a detention. Let's see, 180 divided by 6. Well, let's see, 6 goes into 18 thrice. Throw a 0 on it, 30. So x is equal to 30. Hey, oh, that also answers the first angle. I'm going to give these names. Why not? I'll say angle 1 is equal to 30 degrees. Angle 2, oh, wrong notation. Measure of angle 1. I caught that one, though. You guys didn't correct me on it. Still counts as my win. Measure of angle 5 is going to be just 5 times 30. So the measure of angle 5 is going to equal 150. Or if I didn't want to use the formula, what's another way I could have found angle 5? No, angle 2. Guys, just too hot. I'll turn this into a loop-de-two. There we go. That's just so great. So great. Okay. All right. We've got like 13 minutes. We can skip that. Oh. I did really like this one. This one won't require... Thanks. Thanks, Jack. You ruined my video. All right. So this one, I'm not going to write anything on this. One of the things with geometry that will somewhat be frustrating will be the fact that we have these drawings that look like something's true, but we can't assume it's true. All right, so here's a drawing. It says, here are some things that you can conclude from the diagram below. I can conclude that all points are coplanar, that A, B, C, D, and E all exist on like some flat surface. Now, if I had drawn like a cool like little box rectangle thing and like tried to make this look three-dimensional, it could have looked like E was traveling out in a different path, but it doesn't. We're imagining all of this on one flat plane, and these just happen to be different angles going out on that plane, okay? So I could conclude that correctly. Cha-ching. Points A, B, and C are collinear. I can conclude that. And B is between A and C. That makes sense. Okay, they're all in one line. I like it. I could conclude that line AC, ray BD, this guy, and ray BE, that guy, intersect at point B. That makes sense. This is a common intersection. I like it. All right, can verify. I can say that angle DB and angle EBC are adjacent angles. All right, so angle DB and angle EBC. These guys are adjacent. They share a side and a vertex. Affirmative. And I can conclude that angle ABC is a straight angle because this is a line. Okay, so that big angle, straight angle. Also, look at the notation to describe this straight angle. All right. I just think that's interesting. I don't know if you noticed that yet. That I can verify. Point E lies on the interior of DBC. Okay, so the big angle here, E is on the inside. Those are things that are true that I can conclude. The following are not necessarily true. I cannot conclude the following based on the sketch. Where's my cursor? All right, here we go. Bam. Oh, it just done disappeared. You saw that, didn't you? It went ghost. You cannot conclude the following. Where's my scroll bar? There it is. I can't assume that AB is congruent to BC. Here, I'll even label it. AB congruent to BC? Wrong. I don't know that. I wasn't told that B was a midpoint. Okay, so just because it looks like it doesn't mean it's true. I cannot conclude that these two angles are congruent. I don't know that. I wasn't told that this was an angled bisector. I wasn't told that, okay? I cannot conclude that ABD is a right angle. This, I think, is going to be super frustrating to you guys. You'll want to be like, that's a right angle. It looks like a right angle. You could even take a protractor and measure it, and it looks like a right angle, but we cannot assume that based off of the sketch unless someone labeled it as a right angle or gave you the fact that it was a right angle. All right? So there we go. That's the idea that when we have a geometric sketch, it might look like a square, but you can't say it's a square unless you know. That's the idea. Geometry can be frustrating sometimes. It's okay, though. It's going to be okay. All right, thanks for watching, Internet friends. Have a great day.